Our next section in probability is going to talk about how to find independent and dependent events. So first, let's define what is an independent event. It sounds basically exactly like what it is. An independent event is when the occurrence of an event does not affect the occurrence of another. So you're thinking about questions like, if you have a deck of 52 cards, does drawing a king on my first draw affect my chances of drawing a queen on my next draw, sort of thing. So we want to be able to tell if events are independent. So to tell if events are independent, we're basically checking a product. So what we're looking at here is you're checking two things. The probability of two events A and B um, are independent if and only if the probability of A and B is equal to the separate probabilities multiplied together. So we're looking at, for example, example 1, a bag contains 6 pieces of paper, numbered 1 through 6. A student randomly selects a piece of paper, replaces it, and randomly selects another paper. What we want to do is determine if randomly selecting an odd number, a 5 first, and then selecting an odd number second are independent events. So we have two things happening, the probability of A and the probability of B. So we can define A as selecting a 5 first, and then we'll let B be selecting an odd number second. Okay, so what we want to do then is we want to figure out the probability of three things, A and B both happening, and then A and B separately. So if you looked at the directions, it says to use a sample space. So we want to use a sample space to determine whether or not our events are independent. So when you see that sample space, what I want you to do is I want you to make sure you've listed out all the possibilities. So you might want to, do a tree diagram or list out all your possibilities, but we want to determine all outcomes. So let me go ahead and write down my sample space if you want to try that out yourself as well. Let's see what we get. All right, well, hopefully you found that there were 36 different options because if you notice, we are replacing the paper. So if you draw one first, you're putting that one back and you can draw it out again. So you have a total of 36 different options. And remember to check if it's independent, we want to see what's the probability of A and B happening, and then what's the probability of A separately and B separately, and we're going to multiply them together to see if it checks out. So why don't we look at that joint probability first? So if we want to select a 5 first and then an odd number, what would that be? Well, if I want a 5 first, then I'm only looking at this row and an odd number, which means I have 5, 1, 5, 3, and 5, 5. So that means I have 3 out of 36, and that reduces down to 1/12. So again, that was our joint probability, A and B put together. Okay, so then what we want to do is we want to check, does the probability of A separately times the probability of B separately also equal 1/12? Because if it does, then we have independent events. So now let's take a look at what's the probability of just A selecting a 5 first. Well, then we have 1, 2, 3, 4, 5, 6, right? So those are all the possibilities of selecting a 5 first. So then we get 6 out of 36. Okay, and we know 6 out of 36 reduces down to 1/6. So then our last component then is finding out the probability of B. So the probability of B is selecting an odd number second. So it doesn't really matter what the first number is, but what's the possibility of selecting an odd number second? Well, then we look and we have here 1, a 3, right, a 5, then another 1, then another 3, then another 5. And go ahead and finish this off and you guys tell me what is the probability of B. So hopefully you figured out there are 18 possibilities of picking an odd number second. So 18 out of 36 then reduces to 1/2. So the final thing we need to do is double check if it's independent. So remember, it's independent if and only if the probability of A and B, which we got as 1/12, is equal to the probability of A times the probability of B. So let's go ahead and check that. Is 1/12 equal to 1/6 times 1/2? Well, the answer there should be yes. Right, so just make sure you show me that work, and then we'll see that 1/12 equals 1/12 equals 1/12. Check. So then we can say that these two events are independent, right? Selecting a 5 first and selecting an odd number second do not affect each other. All right, so just make sure at the very end you state your findings, right? So that randomly selecting a 5 first and randomly selecting an odd number second are independent events. Okay, so go ahead and try example 2, same idea, checking for independence with this group of 4 students. But keep in mind that once a person is selected, you can't reselect them. So if you select a boy first, then there are no boys left to select second. Okay, so keep that in mind and think about how that affects your sample space. Go ahead and try that, and then let's come back and check. Oh, don't forget to write down your whole sample space too. So as you're working, double check your sample space. We should have a total of 12 possibilities because you can't do girl one, boy, boy, right? So think about that as you are checking for independence. All right, well, hopefully you got not independent, and as always, check my math, but I do want to see all of this work. So I want to see you show me how to calculate the probabilities, right, and the check for independence, and also your final conclusion, your final deduction. So here they are not independent because you see the product doesn't equal that probability of A and B. Okay, so those are independent events. We also have dependent events and what it's linked to, conditional probability. And let's go ahead and define that. So if independent events mean the events don't affect each other, dependent is going to be the opposite. That means when the occurrence of one event affects the occurrence of the other. Okay, and then linked to that is the idea of conditional probability. So this is when you put a condition on it. So conditional probability is basically the probability of any event B happening given that the event A has already occurred. So an example of conditional probability might be you're looking for the probability a student picked at random is in Ms. Huang's class given that the student is a geometry student. So you're assuming first the condition that the student is geometry has already happened, and then you're looking for, who's in Ms. Huang's class, versus just the probability of any student out there is a geometry student. So you're kind of making a subset, okay? So these two ideas are linked. Conditional probability is also written in this following notation. So you'll see this probability with B and a vertical line A. That's read as the probability of B given A. So meaning A has already happened, what's the probability of B? So the condition is always the second part. So the probability what we're looking for is the first letter, right? The event B, given the occurrence of A. So how do we calculate or how do we determine if events are dependent? Well, there's an equation for this as well. So if you're looking at two events A and B, the probability of A and B should equal the probability of A times the probability of B given A for events to be dependent. Now connected to this, we can also solve for the conditional probability so you can determine what is conditional probability. So if we simply just divide probability of A to both sides, we can solve for the conditional probability. So then if I'm ever asking you to, for example, find the probability that a student chosen at random is a girl, given that the student is in Ms. Huang's first period class, right? So if you have that situation, then you know, oh, well, the event B is the student is a girl, and the event A is that they are in Ms. Huang's class. So then you can, work with that equation to solve for your conditional probability. Okay? Let's go ahead and stop here and we'll finish the rest of these examples in class. So if you have any questions about independent or any of the vocabulary here for dependent and conditional, come back and ask, and then we'll wrap up the rest of the examples and hopefully make probability a little bit clearer together in class. Thanks for listening.